Now it's asking for the volume in the cylinder after the temperature is raised. This is Charles' law. This is Charles' law. If we have a free sliding cylinder or piston, whatever, that just means the pressure is going to be the same. Like, we're not confining it, so the pressure is not building up. It's just remaining the same. So we have Charles' law, which is V1 over T1 equals V2 over T2. V1 was 28, I think, inches cubed. So we can have 28 inches cubed over degrees Rankine. That was 505. And that has to be equal to the volume, and this was like 200 plus whatever, so 660. I'll multiply both sides by 660, and see what I get. So I get, what, 36.594. This is volume, so it'll be inches cubed. This temperature, the units cancel out with the units there, so I just leave with inches cubed. So there we go. Alright, moving on. This is easy. This is very easy. Every time I do this, I'm just looking for, like, I read the problem and immediately I try and predict what law I'm going to use. Boyle's law, Charles' law, or Gay-Lussac's law. So 60-foot cubed compressor tank container has a gauge pressure of, okay, when they say gauge pressure, I automatically think, oh, I might need to change it to absolute pressure. So it has a gauge pressure of 160 psi and a temperature of 70 degrees Fahrenheit. So they give me pressure and temperature, and that's Gay-Lussac's law. So the temperature after some time decreases to 40 degrees Fahrenheit. I'm going to have to change that to absolute temperature, Rankines. Find the final pressure in the tank, assume the standard atmospheric pressure, sketch and label all known and unknown values. This is silly. It's just a tank with like a gauge, some kind of gauge on it. Like, what? Why? I don't. That's dumb. But it wants us to label stuff. So the volume, a compressor tank volume equals 60 cubic feet. Ooh, cubic feet. Do I need that? Well, if I'm using Gay-Lussac's law, I do not need it. So that's just extra information. 160 psi, that's P1. And that's the gauge pressure, though. That's the gauge pressure. We will need to convert that. And the temperature is, so T1 equals to 70 Fahrenheit, so I'll have to convert that. The temperature after some time decreases to 40 degrees. So T2 is 40 degrees. Alright, so if we're decreasing the temperature, then the pressure is going to decrease. Find the final pressure in the tank. Assume the standard atmospheric pressure. Okay, so we're going to have to add stuff. Okay, that's. I bet number 8 is going to tell us what to do. And sure enough, what are the absolute temperature readings initially and after the temperature decreases? So temperature, that's just the temperature plus 460, right? We need the absolute temperature. So the first one is 70 plus 460, which is 530 degrees Rankine. You need your units. Same formula. And it decreases. Remember, the temperature decreases. Sorry, brain fart there. Plus 460. So what is that, 500? Degrees Rankine. Cool. 9. What is the absolute pressure? Well, that's plus 14.7 psi. Plus, we're adding 14.7 psi because the gauge pressure is what was given, plus the standard atmospheric pressure. So then we get, I'm just going to write the answer down. This one would be, no, I'll write it down. The gauge pressure initially was 160 psi plus the atmospheric pressure. So that's 174.7 psi. You can do psi, you can do pounds, divided by inches squared. And then what else? What else? What is the absolute pressure of the system after the temperature decreases? Now we finally get to use Boyle's law. No, sorry, Gay-Lussac's law. P1 divided by T1 equals P2 divided by T2. And it's asking for the absolute pressure after. So that's asking for P2. I know I labeled it P1 and P2. Those weren't really P1 and P2 because we needed absolute. After I changed to absolute, that's P1. So, what was that? That was absolute pressure. Well, that's 174, right? 0.7 divided by the first temperature, which was 530. 530 equals to P2 after the temperature decreases, and then it decreased to 500 degrees Franken. I multiply both sides by 500, and I get 164.811. What are my units? This is pressure. I get PSI. Oh, very nice. The volume of the tank didn't matter because it just stayed the same. It didn't tell us that it was moving at all. Okay, moving on. You know what? I'll continue the rest in another video.